Hello dear students. So in this session, we are going to discuss about bond energy and enthalpy of formation. Okay. So in our previous class, we were discussing the applications of Joule-Thomson's coefficient to real gases, that is inversion temperature of a real gas. So that was the results or the outcome of Joule-Thomson's effect. So that was the second results what we observed that at a certain temperature, so even though a cooling effect was observed when a gas is passed from the higher pressure to the lower pressure, so we were observing the cooling effect, whereas once at a certain temperature is crossed, so the heating was observed. Okay, so that temperature was called as inversion temperature, and hence inversion temperature is the temperature above which heating is absorbed and below which cooling is absorbed during a adiabatic expansion of an ideal gas. Okay, so this is what was discussed in our previous class. This is very important, what is meant by inversion temperature. So based on that inversion temperature, we are going to see the three different cases, that is for some gases like except hydrogen and helium, so they were producing a cooling effect, whereas beyond that inversion temperature or below that inversion temperature, or if we observe these gases where we found exception, that is hydrogen and helium gases, they were not producing cooling effect, whereas beyond this inversion temperature, so these gases also were observed to produce a cooling effect. Okay. So this for this experiment or the observation what was made by Joule-Thomson's. So they derived another relationship which was between the initial temperature T and the fall in temperature, that is delta T. Okay. So there we saw three different cases. So means how the reaction, or how do we going to calculate the inversion temperature. Say for example, if the initial temperature is equal to the inversion temperature, so then how to calculate the coefficient of real gases. So that was the case 1 what we studied, and in case 2, so we saw that suppose if the initial temperature T is less than the inversion temperature, so how we are going to find out or determine the Joule-Thomson's coefficient to real gases. And the third one was if the initial temperature of the gas is more than the inversion temperature, that is greater than the inversion temperature, so then how we are going to determine the coefficient to the real gases. So these three cases were discussed in our previous class, right. So in this session, in today's class, for another 20 to 25 minutes. So let us concentrate on what is meant by bond energy. Okay. So bond energy is also called as enthalpy of formation. Okay. So we all know that in chemistry, for a molecule or a compound to be produced, so there should be existence of chemical bonding. Okay. So this you have already studied in first semester under chemical bonding, how the bonding is going to take place, how the two elements due to their lack of electrons in the outermost ring, by sharing and gaining the electrons, so they are going to form the bonding. Okay. So this bonding between the two elements will be due to the interaction or intermolecular force of attraction between the two elements. Okay. So that is because one of the element will be having a excess of electrons which will be revolving around the outermost shell of the nucleus. Okay. So which those electrons are called as valence electrons, and the other element will be having a deficiency of electron at the outermost cell, where it will be in a tendency to attract, and it should attain a 8 electron rule. Okay. So it should come to a stable form. For that reason, so there will be a intermolecular attraction between the elements. Okay. So that is why, so that force of attraction will make those elements to form a bond, and thereby they the each atoms will be converted into the molecules. Say for example, if we take water, so there in water the oxygen which will be having a deficiency of electron, which will attract the hydrogen towards it, and that hydrogen will make a bond with it, and it will be converted into a molecule. The oxygen atom and the hydrogen atom, they both will share the pair of electrons in them, and they will form a molecule. So that molecule will be stable, which is called as H2O, water molecule. In the same way, sodium chloride or sodium hydroxide, we can take any of the examples. Okay, so here the bond has been formed. So this interaction or the force of attraction between these two elements, so that might be called as energy. Okay, so energy. So how do we define? Say for example, if we it is a general example I am giving to you. So if we have to find out how much close two friends are, say for example in your class only, take an example of Nikita and Sushmita. So they are very good friends, very close friends, right? So how to check how close they are, or how means how the bonding between those two are there. So how do we check? So you just separate them, you just means stop them to talk with each other, or no contact with each other. So that results, or that will give us, so how affectionate towards them they both are, and how the force of attraction towards their friendship is there. So likewise we are going to determine, right? So in the same way, so here the energy which is required to dissociate 1 mole of bonds of a particular type of a compound defines bond energy. Okay, so the bond energy is defined as, so how much of energy is required to break that bond, that means to get dissociated. So how I took the example of water molecule H2O. So to break the bond between the hydrogen and oxygen, how much of energy is required? So that energy is in turn the measure of bond energy. And okay, so now let me define bond energy. So bond energy of any particular type of bond in a compound may be defined as the average amount of energy required to dissociate 1 mole of bonds of a particular type in a compound. Okay, so how much of energy is required to dissociate the bond is the measure of bond energy. Okay, and it is equal to the amount of energy that is released when 1 mole of bonds of a particular type of formed, and hence it is also called as enthalpy of formation. Okay, so this is how we are going to define the enthalpy of formation of the bond or bond energy. So next, so let us see how do we calculate the enthalpy of formation, that is heat of formation of a compound. So the bond energy values of various bonds in the compound are to be known, and vice versa. Okay, so to know the enthalpy of formation, so we should be aware of what is the bond energy of the compound of the various bonds, and that has to be known before we go and calculate the enthalpy of formation. Okay, so let me call this enthalpy of formation of a compound as delta H. So delta H will be equal to, so the amount of energy required to dissociate all the bonds of the reactants. Okay, so what and all the bonds are observed in the reactants, how much of energy is required to dissociate all the bonds which are present in the reactants, minus, so the amount of energy liberated during the formation of the products. Okay, so how much of energy is liberated? So this gives the enthalpy of formation of a compound. Okay, so let me repeat it again. So the amount of energy required, how much of energy is required to dissociate or to break down all the bonds which are observed in the reactants, minus, so the amount of energy liberated during the formation of products. So this is how we are going to calculate the enthalpy of formation of a compound. Okay, so or in other words, we can also explain it as so delta H, that is enthalpy of formation of a compound, is equal to the bond energies of all the bonds of reactants minus the bond energies of all the bonds of the products. Okay, so this is how we are going to calculate the enthalpy of formation, or it is also called as heat of formation of a particular compound. So now let us take one example. This is a simple example, just like how I took an example of water molecule. So here also we are going to get the product as water molecule. Okay. So the problem is calculate heat of formation of a reaction H2, which will be in a gaseous state, plus half O2, which is in a gaseous state, which gives rise to H2O, that is the product, that is 1 moles of H2O is formed. Okay, so they have given the bond energies of H and H, that is hydrogen bonding, hydrogen bond. Okay, so what is the bond energy of hydrogen bond? So this is quite common. Okay, so these are all the common values. Okay, wherever you see hydrogen bonding, so the bond energy between these two hydrogen will be 436.8 kilojoules. Okay, and oxygen double bond, O double bond O, that is oxygen double bond. So the bond energy of this double bond is 495.6 kilojoules, and the oxygen hydrogen bond, so this bond energy is 466.2 kilojoules. Okay, so this is the given information along with this problem, along with this reaction. So they have also given the bond energies of different bonds which are involved in this reaction. Okay, so if you observe in this reaction, so here H2O is the product, so definitely we should have hydrogen bonding. Okay, and oxygen bonding should be there. Okay, and also the OH bonding will be there. Okay, so all the bond energies they have given, and they are asking us to calculate the heat of formation of water. Okay, so we know that, so heat of formation of water, that is delta H, is equals to bond energy of H, that is hydrogen bonding, plus half of the bond energy of oxygen bonding. So these two are the reactants. Okay, so here if you observe the reaction, so this is what is defined. So delta H is equals to the bond energies of all bonds of the reactants. So that is why here the reactants are, so H2, hydrogen bonding, H2, and here O2, so half O2, even though if it is half O2, so two atoms of oxygen are there, so definitely the two atoms of oxygen will be bonded with the double bond. So that is why I have taken O double bond O, that is oxygen double bond oxygen. Okay, so these two are the reactants, minus, so this is the minus, so the bond energies of all the bonds of the products. Okay, so here the product is H2O. Okay, so here I have hydrogen and oxygen bonding, so that is why, so how many I have 2. Okay, since 2 hydrogen is there, so 2 hydrogen oxygen bonds will be present, so that is why 2 into bond energy of oxygen and hydrogen. Okay, so I know all the values, that is H, hydrogen bonding, so the bond energy of hydrogen is equals to 436.8, I have substituted the value here, plus the bond energy of this is half. Okay, so half O2, so this is half O2, so that is why the bond energy of oxygen double bond oxygen is 496. So 496 into 2, so that is 2495.6. Okay, so substitute these values, and bond energy of oxygen and hydrogen is this much. Okay, so by substituting this value, so I am going to get minus 247.8 kilojoules. Okay, so minus 247.8 kilojoules. So here, so they have made a mistake. So this is not 2495.6. So here, please make the corrections.